Hi friends, welcome back. After looking at singly linked list and doubly linked list, now it is time to see what a circular linked list are. So we have two types of circular linked list, one single circular linked list and other double circular linked list. A, si- a single circular list is one where the next of the last node represents the first node. So this makes a complete chain. So it's a circular. And in case of a doubly linked list, the next of the last will be the first one, and previous of the first one will be the last one. So next of the last is first node, and previous of the first node is the last node. So in the singly linked list, we can keep on traversing round and round and round in one direction, whereas in doubly linked list, we can keep traversing round in either clockwise or anti-clockwise or forward direction or backward over and over again. So why do we require such a circular linked list? So first thing will be if we want to have a continuous traversal around a given set of numbers, then we could have a closed one, a circular linked list. It will be more efficient in insertion and deletion, and then we can have a better memory utilization. So the effective memory utilization we can see when we are working with concepts like queue, then it is easy to implement and useful when we are working with elements which to be looped so that they should need to be traversed in a sequence again and again and again, and very much useful when we are going for scheduling like round robin and all that. So many applications of circular linked list we have. So just see as an example how a single linked list is created. So we create a node and then the next node, then the next node. So that's a normal way we create a linked list. But only thing additional we do is the next node of the last node is same as the first node. So we make a round connection and make it a, whereas in the earlier case this was called head and this was called the tail, and next of the tail was supposed to be a null, whereas now next of the tail is no more null, it represents back, and hence now onwards there is no need to call any particular node as a head or tail. So any node can be a head and the previous node to that will become a tail. So want to insert, so we can begin with an empty list, and then after inserting one node, just it's a single node and next node is itself, and if we want to insert another node, then next of this will be the new node, and then we get back to the first node. So we can insert in the beginning as we have done. So the last node was presenting this particular node. Instead of this, we insert a new node with a value of 5, and next of that will be showing to the node of value 2, and this next of the last node will go back to this new node. So this way, new node is inserted at the beginning, or it can be inserted at the end, or can be inserted at the any position. So it doesn't make much sense because we are talking about a circular linked list. So there is nothing like beginning, end, center, and all that. Because all around, if you look at it, anything can be called head, anything can be called a tail, with the other two appropriately called. Now, when it comes to deleting, so whenever you are trying to delete a node, then the next of that previous node has to move to the next one. So here we are trying to delete the node 2. That means prior to node 2 was this one. The next of this will be the next of node 2, and this will be deleted. The memory allocated for this will be released. Same way we can delete in between. So it's the same activity as we did in the singly linked list. The only thing is it's a closed one. So I'm not just spending extra time on coding this and again doing all these activities. Only one change we need to do. Whatever we have seen in the singly linked list, the same thing happens here, or except one change. The next of last node will be the first node itself. So that's the only change we have. All other things will remain same. So inserting a new node, deleting a new node, searching in the circular linked list, or traversing in a uh, circular linked list will be the same. So the advantages of circular linked list is the last node points to the first node, so there are no null references required, so making traversal easier and reducing the chances of encountering null pointer exceptions. So we do come across null pointer exceptions when we are working with normal linked list, but now there won't be any null pointers, and hence encountering a null point exceptions are no more there. But yes, we do have a problem that we may end up in a infinite loop if we just don't know when to stop, if we are interested in having a limited movements. But if we are interested in having indefinite movements, then best nothing to worry at all. So we can traverse in the list from any node and return to it without needing to restart from the head. So that was a problem when we were working with single linked list. Say whether it is traversing or searching, every time we had to start from the head. Now we don't have to start from the head. Wherever we are, just we start moving from there and start searching or traversing. So make sure that the when we come back to the same node, we should stop working. So that one extra thing we need to put in the while working in this search. And they are easy to implement, especially the circular queues where the last element connects back to the first one. And this makes very efficient resource management. So when we are working with the queues, let's revisit this and say that why circular linked list is more efficient in case of resource management. So when we are working with queues, we understand what is going wrong and how this circular linked list will help in improving the efficiency. So each node has a reference to the next node in the sequence. So although it doesn't have a direct reference to the previous node, like a doubly linked list, we can still find the previous node by traversing all the way. So in case of singly linked list, if we wanted to go back, it was not possible. But now, yes, it is possible if we know that our linked list has got n elements. Then if I want to go back one step, then I just traverse n minus one step forward. Then I am at one step behind. So that's another way. We don't have to create a doubly linked list just because we want to go back. So with a same singly linked list with additional movements, we can go backward also. So that's a advantage of a circular linked list. Yes, nothing comes free. There are some disadvantages like more complex to implement than singly linked list. Of course, yes. Then traversing without a clear stopping condition can lead to infinite loops. So that's what we discussed earlier. So we need to exactly know when to stop traversing. If we know that there are n nodes in our circular linked list, then we should ensure that we don't traverse more than n nodes. Otherwise, we keep moving round and round and round and can go into an infinite loop, especially when we are searching any element, and if such element does not exist in the linked list, then we keep on moving next and next and next. And if we don't know when to stop, then it keeps on checking and it ends up in an infinite loop. So we should be very careful in handling these infinite loops. So make sure that the size of the circular linked list is well known in advance, so that while traversing, we must ensure that more than n nodes are not traversed. So debugging definitely is more challenging due to the circular nature, as traditional methods of traversing may not apply here. So because we end up somewhere when we are talking about normal, but in this case it keeps on round. So there will be uh, problems with debugging when we are working with a circular linked list. The applications of a circular linked list. So it is used in for time sharing among different users, like round robin scheduling mechanisms in multiplayer games where, for example, the people keep moving around the chairs, and each time one chair is reduced, so we have that game. So if we are playing such a thing, then it keeps moving round and round and round, and yes, this the circular linked list will be best way to implement such a game. And circular linked lists are often used in buffering applications such as streaming data, where data is continuously produced and consumed. So when we are discussing about the producer consumer problem, we understand how the buffer with a circular linked list is more preferred than a normal linked list. So these are some applications we have for our circular linked list. So many more issues to be discussed in the coming sessions. So we continue our sessions. So please keep watching, and if you find these videos of any use, please don't forget to like and subscribe the channel, and please tell your friends to watch and subscribe. Thank you.